Okay, so I will start sharing then.
Yes.
Okay, and let's get started. Um, all right, so I have got two talks. I'm going to cover a lot of material today. This first talk, and I broke it into two talks because logically they're you don't have to go through like 2 hours of presentations. And I know that we want this to end at a particular time, and we also want to have some hands-on at the very end to make sure your accounts are working. So Cindy and Susan, no matter how far I get or don't get in both of my talks, let's make sure that I stop with about 20 minutes left remaining so that people can, we can verify that they can log on. Just ring a bell or just interrupt. And I will stop for a few moments for questions between the two talks. So this talk will just talk about the basics of how to get onto Expanse. Not a lot of discussion about the architecture. We'll cover all of that in great detail next week. And we're just trying to make it so that today you leave with a feeling that you can log on to Expanse and the user portal and what that means, and that all of that's working, and have some understanding of getting connected and the things you need to do to be able to work on Expanse right away. That said, you'll have training accounts, and a lot of that will be set up for you and customized, which is the advantage of the training accounts. So with that, I'll give you just a quick, this is Expanse, and it's located at SDSC. That's the main lobby, which next year you'd be able to see if we were in person. So Expanse has 13 scalable compute units, and these are unique because they're designed to conduct both CPU, GPU, and store some data all on one rack, so you have high-speed communication. So it's got CPU, GPU, it's got a large storage, parallel file storage systems with high-speed network, and it's designed for what we call the long tail of science, not for most people run really important codes, but they don't require a million cores. And so we're in that group of people that a few thousand, 10,000, 100,000 might be good enough. And so you could run on Expanse. And it's designed for that on purpose. So if you find your model really needs to be on a bigger machine, we'll help you figure out where you need to go. With that, that's all I'll say about Expanse. It looks like this in the machine room. If we could do a tour, you'd be walking by and you'd see these are what we call the racks. There's CPUs and GPUs and cables connecting the cooling and electrical. It's really interesting system, and someday we'll be able to do tours. Okay, so getting connected. First of all, to get connected, there's a few basic skills you need to have, and we have a repo with introductory material like Linux. Unfortunately, you do need to know Linux to run jobs on Expanse from the command line. The portal helps smooth that for you, which is, I encourage you to use it if it works for your applications. So you need to understand that, what Linux commands are needed, and we have some good training material for that. We won't go through it. You can do it on your own, hopefully. You need to understand security and authentication, how to use GitHub for our material, and just out in the HPC universe, a lot of things are on GitHub repositories now. And we'll talk about that next week, and we also have a simple tutorial, Unix and Linux, and then the environment, accounts, modules. It can be a lot of layers of software that you have to learn about and debug when you're making changes to your code or you're running a new application. So the purpose of this institute is to give you a fast overview, but by no means does it simplify the task ahead. But we do have a lot of material to help you navigate it. So there's ways to connect to Expanse. You can do it through a terminal application, and you could access interactive compute nodes. I'll talk about that briefly. You can connect using the Expanse user portal. Most of our presentations next week and our hands-on will be through the portal, because it really does eliminate a lot of the Unixy stuff you might need to do. But if you're in a situation where you have to move on to logging on and compiling code and stuff, we'll help you with that, and we've got material for that. This is a web-based connection, and it's got applications built into it, Jupyter Notebooks, MATLAB, R, and others. And you can also use a terminal connection. And a lot of people connect directly using Jupyter Notebooks, and we have software on that, and we'll talk about that in detail next week in our interactive computing session. So to log on, we use a single sign-on through the Exceed user portal, but the caveat is, and Bob will probably talk about that next week, is Exceed is converting from, it's been around for over 10 years, and NSF is converting it to the Access program, which is a new multi-tiered refactorization of Exceed, which is the gateway to all of the NSF cyber infrastructure resources. So right now, though, you can still use the Exceed portal or from the command line using Exceed password from the user portal. Again, that gives you terminal access. We'll show you that today. CPU and GPU resources, note that they are allocated separately. So if you don't have them both, you'll have to apply for an allocation. But the login nodes are the same to get onto the CPU and GPU. To log into Expanse, the host name is login.expanse.sdsc.edu. I already saw somebody helping with that information, a student helping another student to clarify that. And the command is your username, SSH, your username at login.expanse.sdsc.edu, or SSH-L, your username, login.expanse.sdsc.edu. And if you're lucky and your username on Expanse happens to be your username on your laptop, you can skip this part right here. When you log on, you'll be assigned to one of two login nodes, Login 1 and Login 2. They both reach the same data, your same file system, but it's just a load balancing. Okay, so you can use a public key, SSH keys, to access Expanse, and we have a tutorial in our security repo helping you figure out how to do passwordless access. It's a very specific way of setting it up, but once you do that, you don't always have to type in your password. I think it's in this webinar here, and you can find the information how to use SSH agent forwarding. This is a trusted method where you have to authenticate, and the agent authenticates you and helps you get material, your keys copied over to the remote host. And once you do that, because you had to use your username and password, it's trusted from the machine that you're on to the machine that you're going to. It's a one-to-one relationship. You can do forwarding, but that gets a little more complicated. For now, just use your username and password. You can play with that if you want with your training account. So accessing the system gets a little confusing if you're really new. First of all, you would use something called a terminal on Linux and Mac. It's built in, a Linux terminal, and on Windows they have, I understand it's at Windows 13 now, they have a terminal app that emulates Linux pretty well. And so if you can be working in those environments, life is simpler. You can also use other apps called like PuTTY and Cygwin. The problem is they don't always emulate all the Linux commands you might want them to have. Over here is a cartoon diagram of what a cluster looks like. You are the user sitting at your laptop. You use SSH to connect to one of those head nodes or login nodes. There's two of them, and it doesn't matter which one you get onto. And then you want to use these high-end compute nodes, but it's not that easy. You have to get permission, you have to have allocations, and you also have to submit a request to use one of these. If you have, there can be last night I looked, there were 6,000 jobs in the queue to run, either running or pending. So you can't have 6,000 people randomly choosing a node to work on. Okay, so what we do is we have something called a scheduler, and I'll talk about that today in the next presentation. So when you log on, you'll be looking at your code, figuring out where your data is stored, maybe on the parallel file system, maybe just locally, and then you'll submit a request to run a job on these remote nodes. And again, there's the IP address and login.expanse.sdsc.edu. But it's hard to remember when you get on this login node, that's only for managing. You don't run your jobs on it. You won't be allowed to. But that's just for you to get organized so you can figure out how to run your jobs on these compute nodes. So once you connect via a shell terminal, you'll get a welcome message and then some greeting information and usually updates if there's any work being done on the system or something like that. And you can run basic commands like what's the date, the host name will tell you which one you're on. There's a command called SQ, I'll go over that. It tells you what jobs are running. This was from last night and that's when I saw, this time there was 4,394 jobs running or pending. That's a lot of jobs. But that is a very busy, very popular machine. And you can also do file listings to see what's in a folder. Like this one here, you want to write this down, CM Shared Examples, SDSC. This directory has a ton of examples put together by our user support people, like Mahidar does a lot of them, and Marty and other people. We keep code in there that you can grab and use as examples. Okay, so using the login nodes properly, do not run your code on that. Don't try to launch a Jupyter notebook. You might be able to try and start one, but it'll get shut down. It's not meant for that, and people forget, and so that their job might get terminated. We want you to, it's a bad use of that node because other people, they're just logging on, they have trouble logging on. So don't use it for intensive processes. Don't run a workflow. Don't use it as your primary data transfer. If you have to move data like a terabyte of data onto the parallel file system, we'll show you in our data management talk next week how to get an interactive node with high-speed connection and use it for your file transfer. Don't use it to run notebooks and other popular applications. Get an interactive node. I'll mention that briefly today. Login nodes are not the same as the batch nodes or the compute nodes. Okay, so we'll work mostly this week with the user portal, and we'll give you an example at the end of my second. Maybe I'll do that now, depending, but we'll show you how to use the portal at the end of the day today. So you can actually, we want to verify that you can log onto the portal, but you can look at your files that are on Expanse. You can run applications like MATLAB, Jupyter Notebooks. You can build batch jobs. You can open up a terminal. There's a lot you can do with the portal, and it simplifies your work. And we're using it with your training accounts to make sure everybody has the same common environment when they log in. Jupyter Notebooks are really popular, and we have a special way to launch them so that they're secure. By default, Jupyter Notebooks are not launched with a secure HTTPS connection. So we have some software from the satellite proxy service, and we use a client called Galileo to launch them. If you want to do it yourself, you can using Galileo, but through the portal, it uses Galileo to launch notebooks. And then you can run any kind of notebook that you want on an interactive node. Okay, so modules. The environment that you have when you log in, like what's your username? M. Thomas would be me. Train 109 is my training one. Who you are, what commands you can run, what libraries you can use, like for compiling, I'll talk about in the next talk. These all have to be configured, and it's using something called the LMOD system. At first, it's a lot of work to learn it, because you have to make sure that all of the libraries that you want are available. But once you figure out I think of it as a module recipe that you need for a particular application, you come in, you log on, you clear your environment, you load in the module recipe at the time for the particular application that you're running, and then off you go. You can run it, guaranteeing that you've got the environment you need. The paths are already set up, and you're not trying to figure out, do I have the right version? You have an exact environment that you need. And over time, that'll start to make sense. Like if you have one application that you compile with an Intel compiler, you would set up an Intel recipes But if you have another application that just needs the GNU compiler, you can set up a GNU compiler recipe. So you can customize it to the application that you're working with. And so you have to learn how to navigate this. So modules, you may or may not need to load the scheduler depending on whether you're logging onto a CPU or a GPU and other factors. So make sure that you can see the Slurm commands. You won't see all modules that are available when you run this one command called module available, because the ones available will depend on the modules that you've run. It's sort of like I'm going to California and I want to see all the streets in San Francisco. Well, I have to get to San Francisco and then I can see all the streets. But you can't be in San Francisco and then be on a street in LA, so you have to move to the LA. So think of it as you have to customize the environment. That doesn't mean they don't exist, but you have to find them. And when you use this command called module spider, it will tell you what you need to load in order to run and access the particular library or application you're interested in. Module paths are different for CPU and GPU, so we want you to load CPU if you're running on a CPU and GPU if you're running on GPU, but don't load both modules. It can get a little tricky, and so if you get confused, ask the help desk. And these are some of the most popular commands. This is just, excuse me, list the modules that are available, spider, navigate, which ones are available, which ones are loaded for me right now, load and unload. You can load and unload or purge. This will help you. You can swap out modules. Oh, I've got the wrong version of the Intel compiler. I need Intel 1.139 and I have 1.137. So you can also just swap it out. And what's nice about the module system is if you change something, the module system will make sure all of the other library dependencies are taken care of. And that's so much easier than the way it used to be, where you would have to manually get all the paths fixed in your commands and stuff like that. So modules make life easier once you get it set up. All right, a couple of quick examples for modules. I'm going to reset my modules. I've logged in and I have a system default. And so I'm going to list the modules that I get when I first log on. I get a shared CPU, Slurm connection, the SDSC, which allows you to run some commands for like learning about what project accounts you can use, and then something called default module. And so through these 5 modules, I have available to me all of these other modules. So this next one, you can look at a particular module and get information. Like I have MATLAB in my environment and it tells me where is it located, which is helpful to make sure you're getting the right version, and then other information about this module. And so that's a really quick overview of modules. We have more detailed information in the user guide and in Expanse 101 module tutorial where you can learn to use them in more detail. And then account management, finally. So you have to have allocations. You have to have basically the coin of the realm, which is a service unit, an SU. And you guys are on our training allocation right now. And when the course is over, you'll have about a week to download your code, and then you will no longer have that training account and be on the allocation. So you should verify, first of all, that you have accounts that you're on, and I'll show you how to do that. And make sure that you're using the right project when you go to run a job. Your PI of your project that you have allocation on work very hard to get those allocations. They're very competitive, and they want to manage them correctly. So make sure you're using the one that the allocation is intended for on the application you're running. They are granted for specific projects, so be careful with that. And then you'll either be running a batch script and put the project number in there, or you'll do something from the command line and you'll add the project number in there. The left bracket, project right bracket, that's not a valid project number. It'll be like SDS173, typically 6 characters, but this one is just an example. In our tutorials and guides, when you see these double brackets, that's usually just a symbol for real data that needs to go into a command or something else. And I'll give you more examples of that. You'll get more here and in the next tutorial. So part of that SDSC module is called, a command called the Expanse Client. It gives additional details regarding your projects for you and the availability and usage that you've accumulated on them. The script is located here in our CM Shared Apps. Most of the commands, applications that we sponsor and we develop are in this folder. Feel free to go look at that. You can look all through it and get an idea of what's in there. It's there for you to grab code from and try to run. To use the script, you may need to load the SDSC module. If you can't find it, then load it, and you'll find that it's available. So here I'm going to use the Expanse Client user, and the resource that will be queried will be Expanse, and I am allowed to use these 4 projects. Some of them have a project ID for Exceed, and it tells me how much I've used, how much is totally available, and how much has been used by the project overall. That would be informative to the project PI. We do put limits on large allocations for individuals on them, like in our training account, you would have a limit. So then you can also look at which resources are available that you can access. So Expanse GPU, industry GPU, probably you're not going to be able to use those. Those are reserved for industry partners. And you can also look at your projects on a specific example, like resource, like the GPU. Remember, CPU and GPU allocations are separate. If you want to work on both, you have to apply for both CPU and GPU. And again, that just shows the output. Charging, when you run jobs, you get charged money, and that's the service unit. And one CPU core, Expanse is built with the AMD EPYC hardware, and it has 128 cores on each of the EPYC devices. And so one CPU core with less than 2 gigabytes of data for 1 hour. And for the GPU, it's less than 96 gigabytes of data for 1 hour. Shared partitions, you can share a node. You can request the entire node with all 128 cores, and you're going to get charged for that. Or if your code doesn't need all of the bandwidth or all of the memory or all 128 cores on that node, choose a shared partition. And I'll talk about partitions in a moment. In the next talk. Partitions are how we organize the nodes that are on the system into groupings, like, and it's a logical access permission system. So the charges are based on which resource you're on and used by the job, regardless of what you got done. So if you forget to kill your job, or if you just ask for a whole node, all 128 cores, and you only needed one, and you only ran for 5 minutes, you'll still get charged for all those cores. So if you have questions about that before you start using up your allocation, send a note and ask for help to understand more of it, or read the user guide. There's a lot more detailed explanation in there. Charges are based on either the number of cores or fraction of the memory. The minimum charge for any job is 1 SU. So you can quickly use up your SUs if you run a lot of very short jobs. And there's more details in the user guide, and there's the link. Wrapping up, there are user guides and tutorials. We've got the Expanse user guide and a training tutorial, Expanse 101. This is somewhat a hands-on version of what I'm giving you this morning in this talk and the next one on running jobs. And you can copy the code and work with hands-on examples from there. Clone the examples from this tutorial. All of the presenters, where applicable, will upload. Oh, that's right, I have examples in this tutorial. So clone the examples from that. They're based on the ones that are in the CM share folder I described to you above. But you can download them then onto your system and take a look at them. And then we have training resources. Go to this page here where we have a full catalog of all our past training. And then Exceed also has training resources. So that's the end of this talk.